Exponents practice problem by Syed Mohammed Ahmad. So let's just start our today's practice problems. Okay. So these are the questions. Question number one, which is given as this equation and then solve for x. Okay. So basically, what we have to do, we have to find the value for x. So we can just write the equation as this: 3 to the power 10, 9 divided by 3 to the power 6. Okay, so this is the equation. Um, what I have to do, what the question is asking is to find the value for x. So the thing is, we have to isolate x on one side and basically find the value. Okay, so in order to isolate x, what I need to do is, like, I need to remove this thing, right? So in order to remove 3 to the power 10, what can I do is simply I can multiply 3 to the power 10 on both sides. Okay. So you will see that this 3 to the power 10 will be cancelled like this. 3 to the power 10 equals to 3 to the power 10 multiplied by 9 divided by 3 to the power 6. Multiply 3 to the power 10 on both sides, so I have just multiplied them. Now this can be cancelled by this because they are both in the division, they are being multiplied. Okay, 3 to the power 10 multiplied by 1 over 3 to the power 10. So basically 3 to the power divided by 3 to the power 10, they will be cancelled. So you will be just left with x multiplied by 1. X multiplied by 1 is simple x. Okay. Now you can simply write 3 to the power 10 multiplied by 9 divided by 3 to the power 6. Okay. Now there is a rule, there is a one of the laws of exponents, which says, let's say you have any number a and it has some power m divided by the same number a to the, let's say, power n. Okay, so you can write this thing like this: a to the power m minus 1. Okay, this is the quotient rule for the exponents. Now we will apply this law on this point. Okay, so I'm writing here x equals to 3 to the power 10 multiplied by 9 divided by 3 to the power 6. So basically, if you see this thing, I'm just writing them separately: 3 to the power 10 divided by 3 to the power 6 multiplied by 9. So you can just write 3 to the power 10 minus 6 multiplied by 9. So 10 minus 6 is 3 to the power 4 multiplied by 9. Okay. So basically what I have done, I have just like subtracted the powers, okay, the exponents, because this is the quotient rule. Now this is what we have got. Okay. So we can further simplify this thing like this: 3 to the power 4 multiplied by 9. Okay. Can I write line like this: 3 to the power 2, because 3 to the power 2 meaning that 3 multiplied by 3, 3 multiplied by 3 is 9. Okay, so we can write 9 as 3 to the power square. Now there is a property of exponents which says a to the power m multiplied by a to the power n. Okay, a is any number, a is any number. Okay, the rule is these bases, a is the base. Okay, the bases should be same. Okay, so a to the power m multiplied by a to the power n, like powers can be anything, you just need to add the powers: a to the power m plus n. Okay, if you see here, the bases are same, 3 and 3. Now you can just write 3 to the power 4 plus 2, it will become 3 to the power 6. Okay, so the x will be 3 to the power 6, right? 3 to the power 6. So 3 to the power 6 is your answer. X equals to 3 to the power 6. That is your final answer. Now we will do the second question. Evaluate 5 over 7 multiplied by 5 over 7 to the power negative 6. Okay, let me just write them. Write that thing. Okay. So first of all, the question is 5 divided by 7. 5 divided by 7 to the power 6 equals to 5 divided by 7 to the power negative 6. Okay. Now in this case, we have just to evaluate this thing. Okay. It means we just need to simplify it. Okay. So when I was going to simplify this thing, so let's say 5 over 6 to the power, sorry, this is the multiplication in between them, okay? So this is the same thing, right? If you just recall the product rule, this is the product rule. I'm just writing the product rule again, a to the power m multiplied by a to the power m equals to a to the power m plus n. If you see, a is the base and a is same, okay? A is any number, it can be 0.2, it can be 2, 4, 6, any number, negative 2, just these two a's should be same, a to the power m multiplied by a to the power n, okay? Powers can be any number, powers can be negative, positive, anything, okay? So when a to the power m multiplied by a to the power n, so we just write 1a and the powers will be added, m plus n, okay? This thing. So in this case, if you see 5 over 7 to the power 6 multiplied by 5 over 7 to the power negative 6. So this 5 over 7 is, if you just compare it with the law, this law, product rule, so 5 over 7 is basically A, okay? Just substitute A, okay? Let's like, just apply this rule, A to the power n multiplied by A to the power n, okay? So A is 5 over 7. So we can write 5 over 7 to the power 6, and there is a positive sign. The second power is like minus 6, okay? So I can write minus 6 in the brackets, okay? So 5 over 6 to the power 6 plus bracket negative 6, okay? This is because this is basically m. If you just compare it with the rule, um, this 6 is the m power, okay? This minus 6 is n, okay? So I'm just adding the power m plus n here, okay? So when you add them together, so you will get 5 over 6 to the power 6 minus 6. 6 minus 6 is 0, right? 5 over 6 to the power 0. So anything to the power 0, anything to the power 0 is what? So this is also a law, right? A to the power 0 is 1, okay? Anything to the power 0 equals to 1. Any number to the power 0 is equal to 1. It means 5 to the power 6 to the power, 5 to divided by 6 to the power 0 is 1. So the answer for this 5 over 7 to the power 6 multiplied by 5 over 7 to the power minus 6 equals to 1. So this is your answer. Now let's move to the third question, which is question number 3 is 6 q square s cube to the whole square divided by 2 q s to the whole square. Okay, there is a whole bracket. Okay, so first we need to just multiply the powers. Okay, this is the rule. Whenever you have a power and then there is also a power to the that power, okay, so we will just multiply the powers. So q square s cube has the whole power square, okay? So in this case, first you need to like split the powers like this: q square to the whole square s cube to the whole square. We can, when there are two numbers being multiplied with each other, variables or number, so we can basically split them, okay, individual powers into individual powers. So q square to the power square, s cube to the whole square. So similarly in the denominator we have qs square, okay? So we can qs to the whole square. So we can write q square and s square, okay? So this 6 divided by 2. So 2 multiplied by 1 is 2. 2 multiplied by 3 is 6. Okay, so 6 divided by 2 is 3. So I can write 3. Similarly, when there are two powers, so we can multiply the powers. 2 multiplied by 2 is 4, so q to the power 4. And similarly, 3 multiplied by 2 is 6. So it will be q square s square. Okay. This is also a property. Okay, power to a power rule. This is a power to a power rule. Okay, which says, let me just change the color. Which says a to the power m to the power n is basically a to the power m multiplied by n. Okay, so I have just done this thing here. Okay, so now you can just simplify it like this. So what rule we will going to apply here? Just pause the video and write in the comment what rule we will use, the product rule or quotient rule or any other rule you can say. You can just write in the comments box. Okay. Okay. So so what we will do, we will just use the quotient rule, q to the power 4 minus 2. Similarly, s to the power 6 minus 2, because these bases are same, right? Q, Q, S, and S. Okay, so we can just subtract the exponents. So let me just remove it. So it will become simply 3 to the power q. 4 minus 2 is 2. 6 minus 2 is 4. So this is the final answer. Okay, so similarly, we have question number 4. It seems a quite difficult or complex question, but it is not. Okay. The thing is, in question number 4, we also have to simplify it. We have to evaluate it. Okay. So the thing is, we need to see what should be our focus. Okay, in question number 4. If you see, there is 10 multiplied by 5 to the power n plus 4 plus 125 multiplied by 5 to the power n plus 2 divided by 3 multiplied by 5 to the power n plus 3 plus 20 multiplied by 5 to the power plus 1. So this is the question number 4. Okay. Now the thing that we have to do in this question is simply, the first thing we can do here, because this 5 to the power n. Okay. So in order to simplify this question, we need to get rid of this 5 to the power n. Okay, because we need to find an answer in which there is a number. Okay, the answer should be in a whole number. Okay, if it is not being removed, it is not able to remove, so we can just take it. Okay, otherwise first we will try to remove 5 to the power n. Okay, this n. So in order to remove this, let's just do like split the powers. I can split 5 to the power n plus 1 like this. 5 to the power n multiplied by 5 to the power 4. I have just applied the reverse of the product rule here. Okay, the product rule, when two exponents are being multiplied with each other, we add the exponents. Okay, now I have just apply the product rule in a reverse way. Okay, so 5 to the power n multiplied by 5 to the power n 4. Basically, this is the same as 5 to the power n plus 4. Okay, okay. So this is, we can write the parenthesis plus. Similarly, 125 multiplied by 5 to the power n multiplied by 5 to the power 2 divided by 3 multiplied by 5 to the power n multiplied by 5 to the power 3 plus parenthesis, open parenthesis, 20 multiplied by 5 to the power n multiplied by 5 to the power 1, which is basically 5. Okay, 5 to the power 1 is 5. Okay. So now if you see in this term and in this term, just see like this 5 to the power n. Okay, this is common in both the terms, right? 5 to the power n. And there are some other things which are common, but we are just looking to this 5 to the power n. Okay, So 5 to the power n is common in both the terms, right? So I can write 5 to the power n outside, okay? And I can make a square bracket and parenthesis 10 multiplied by 5 to the power 4. These 10 multiplied by 5 to the power 4 is basically left in this first term. Okay, so I can just change the color. Let's say we are using this now. Okay, so this is a positive sign here. Okay, so similarly, parenthesis 125 multiplied by 5 to the power square, right? And there is a whole square bracket. And this whole is being divided by this thing, okay, this thing here. So what we will do in this case, we will similarly take 5 to the power n common, because in both the terms, this term and this term, 5 to the power n is common. So we can take it out like this. 5 to the power n square bracket 3 multiplied by 5 to the power 3 plus 20 multiplied by 5. Okay. Now if you see, these two 5 to the power n is divided by 5 to the power n. So we can cancel them. Clear? So now it is very simple. You can simplify the terms. Okay, so 10 multiplied by 5 to the power 4. You can simplify it, plus 125 multiplied by 5 to the power 2. You can also simplify it. Let's just simplify them. So you can use a calculator for this if you do not know the 5 to the power 4. Okay, let's just use the calculator. Okay, so 5 to the power 4 is basically 5 to the power 4 is 625. Multiplied by 10 is 6250 plus let's just plus we have 5 to the power square, which is 25. 25 multiplied by 125 is 3125 divided by, you can do one more thing. Okay, if you see, you can take you can simplify it, okay, like this. 10 multiplied by 5 to the power 4 plus, if you see, 125 is 5 to the power cube, right? So I can replace 125 by 5 to the power 3 multiplied by 5 to the power square, similarly divided by 3 multiplied by 5 to the power cube plus, and I can write instead of 20 I can write 4 multiplied by 5 multiplied by 5, right? Because 4 multiplied by 5 is 20, right? So I can replace 20 with 4 multiplied by 5. Okay, now I am writing the next step here, okay, on the top. So 10 multiplied by 5 to the power 4 plus, now you can add the powers. So 5 to the power 3 plus 2, 3 plus 2 is 5, so I can just write 5 here, divided by 3 multiplied by 5 to the power cube, it is as it is, plus 4 multiplied by, this is 5 multiplied by 5, so I can write 5 to the power square, because both are the same thing. 5 multiplied by 1 is 25 and 5 square is also 25. So I can just take, if on the numerator I can take 5 to the power 4 as common, because 5 to the power 4 is present here and it is also present here. Like I can split 5 to the power 5 into 5 to the power 4 multiplied by 5, right? So you can basically take these two things out, right, like this, because there are two terms. This is the first term, this is the second term, okay, separated by a positive sign. So you can take 5 to the power 4 as common and you can write the rest of the thing. So 10 multiplied by 1 is 10, okay, so plus 5 divided by 3 okay, in the denominator you can also take what, 5 to the power square common, right? And you will be left with 3 multiplied by 5 plus, there is this plus sign here, okay, and 4, simple 4, okay. So this 5 to the power square, okay, so we can basically what we can do, we can write 5 to the power 4 minus 2 because the bases are same, so we can subtract the exponents 4 and 2, 4 minus 2, so which is 2, okay, so I can just write 2. So 10 plus 5 is 15, we can write 15 divided by 3 multiplied by 5 is 15 plus 4, so it is 19. Okay, so this is the thing, and we can simplify it. Okay, so 3 multiplied by 5, we can say, we can also write it like this because 15 is 3 multiplied by 5, and they all are being multiplied with each other. So 5 to the power square plus 1 is 5 cube. So 3 multiplied by 5 cube divided by 19. So you can say this is your final answer, or you can further simplify it in your calculator. You have one, so it will be 375 divided by 19. Okay, so this is your final answer. Now there is a question number 5. In question number 5, there are two parts. Okay, the first one is very interesting. We have to find the value of x. Okay, let's just do it. The first question is this: 4 to the power x plus 2 to the power x minus 20 equals to 0. And like, if you guys found anything like you do not understand anything, you can ask me in the comments. I will definitely going to reply you. Okay, thank you. So 4 to the power x plus 2 to the power x minus 20 equals to 0. So first of all, if you see 4 to the power x, okay, okay, now like 4 is basically 2 to the power square, right? So I can replace 4 with 2 to the power square, okay? So I can write 2 to the power square, and there is a x in the power as well, plus 2x minus 20 equals to 0. So if you see, we can just multiply the powers. 2 multiplied by 2x plus 2 to the power 2x, and then 2 to the power x minus 20 equals to 0. So what I can do here, we will do the substitution, which is, let's say, take 2x equals to t. Okay, this is the thing. So you can substitute it. So first of all, when you substitute them, so let's say there is a 2 to the power 2x. Okay, 2 to the power 2x. So I can write this thing as 2 to the power x, 2 to the power 2, 2 to the power x, and there is a whole power 2, right? Both are the same thing, right? Because 2 to the power x to the power square is basically 2 to the power 2x, right? Both are the same thing. So what you can do, you can, and we have substituted 2 to the power x equals to t, right? So I can write t, and there is a whole square. I have just replaced 2 to the power x by t, so t square. So here I can just instead of writing to the power 2x, I can write t square. And similarly for 2 to the power x, we have t, so we can write t minus 20 equals to 0. Now when we apply the factors here, let's say we have t to the power square and 5t minus 4t minus 20 equals to 0. But why I have done this is because there is like 5t, positive 5t, negative 4t is basically positive t, right? They both are the same thing, right? And when you multiply 5 with 4, so you will get 20. And negative 20, 5 multiplied by negative 4 is negative 20. So this is how we will write 5t minus 4t. Both are the both equations are same. T square plus t is basically t square plus 5t minus 4t. If you simplify this, you will get again t, right? Okay. So we have done this in order to find the factors. Now we can write simply t. We can take in these two terms we can take t as common. So we will be left with t plus 5 minus 4. We can in these two things we can take minus 4 common. Okay. Why we have taken minus 4 common? Because 20 is 4 multiplied by 5. So we have taken 4 as common, negative 4 as common. So negative 4, and we can write t plus 5. Yes, t plus 5, not t minus 5, right? This is because if you multiply them together, so you will get 40, negative 40, negative 20. You will get the same thing. Basically, when we take a negative sign common, okay, negative sign common, so we will switch or swap the signs, okay. The negative will become positive. So we have written the positive t plus positive 5 equals to 0. Now there are two terms here. So this is the first term, this is the second term. Now you can basically take t plus 5 as common, okay? So t plus 5, and you can write in this first term you are left with t, the parenthesis t, negative sign, negative, and in the second term you are just left with 4 equals to 0. So there are two terms, t plus 5, we can take t plus 5 equals to 0, and we also take t minus 4 equals to 0. So t equals to negative 5, t equals to positive 5. In this case, we will eliminate negative 5 because t is basically 2 to the power x. T is basically 2 to the power x. So I can replace t with 2 to the power x equals to negative 5. And if you see, 2 to the power x, for any value of x, 2 to the power x cannot be a negative number. If you substitute a negative value of x or a positive value of x, you can substitute 0, but you will never get a negative value. Which, if you see, there is a negative 5 here, okay, it means cannot be possible. 2 to the power x cannot be equals to a negative value. Okay, so we will eliminate this thing. Okay, we will not take t equals to negative 5, but here t equals to positive 4. Okay, so we will take this thing. So t equals to positive 4. If you see here, 2 to the power x equals to t, we can just replace t with 4. So we can write 2 to the power x equals to 4. Okay, similarly you can say 2 to the power x equals to 2 to the power 2, right? Because 2 to the power 2 is basically same as 4. And if you see, this is like a rule. Whenever you have two terms on both sides, okay, so you can basically, when you have the exponents and the bases are same, if you see there is a 2 here and there is also a 2 here, bases are same, so you can take the powers equal to each other because there is an equal sign in between them. So you can say x equals to 2. So the value of x is 2. So this is the answer of question number 5, part A. Okay. Similarly, now we will do the part 2. Let's just write the part 2. Part 2 is 3 divided by 5 to the power whole cube multiplied by 3 to the power 5 to the whole power minus 6 equals to 3 to the power 5 to the whole power 2x. Okay, so this is the same as both the bases are same, so you can take them just 1 3 to the power 5, and you can add the powers. So 3 plus minus 6. Okay, so 3 plus minus 6 is basically when my plus multiply by negative sign, then you will get a negative sign. So you can just write 3 negative 6, right? 3 negative 6 is basically negative 3. Okay, and then I equal sign 3 to the power 5 to the power 2x minus 1. If you see here, this is same as the previous question, right? This thing. Both the sides are equal to each other and their bases are same, okay? So you can take the exponents equal to each other. Negative 3 will be equals to 2x minus 1. So when you simplify this equation, so let's see what you will get. 3, like when you add, you have to find the value of x, okay? So you have to isolate x. In order to isolate x, add positive 1 on both sides, okay? So negative 3 plus 1 is negative 2 equals to this positive 1, negative 1, positive 1 will be cancelled. So negative 2 equals to 2x. Now in order to isolate x, just divide the terms by 2 on both sides. So this will be cancelled by this, and there is just x here, okay? So x is isolated, okay? So you can just write x equal sign negative 2 divided by 2 is negative 1. So for the second question, the x value is negative 1. For the first question, x value is 2.